Hello everyone, I'm Chanlong Yuan. In this video, I'm going to talk about algebraic and transcendental numbers. I know this topic may seem difficult. Just remember it's one definition and do more practice. You will soon become more and more familiar with it. So, let me explain the flow of the video. First, we will introduce algebraic and transcendental numbers. After which I will open up the thinking questions. Then I will discuss exercise and proving questions. After that is answer for thinking questions. And finally is summary. So, what is algebraic number? A number S is an algebraic number if it satisfies this polynomial equation and all the coefficients are rational numbers or integer. For example, 1 is algebraic since we can write it as s minus 1 equals 0 by its definition. If a number that is not algebraic, then it's called a transcendental number, which means it cannot satisfy this polynomial equations such as Euler number E. So, why all the coefficients must be rational number or integer? Here is the example. This version is an algebraic number since it satisfies the following equation. The left and right equation are the same in terms of algebraic number since we plug s in both equations, we will also get output 0. Therefore, it doesn't matter whether coefficient of the equation are rational or integer because it's just a multiplication and division algorithm. Also, we cannot let polynomial of coefficient be irrational. If do that, then every number will be algebraic. Now, here is the thinking questions. Is that pi an imaginary number and algebraic? And why? Can you prove it on it? Well, maybe you can stop for a while and think about it. Now, I'm going to discuss exercise and proving questions. So you may also continue watching before we answer these questions. Show that 9 over 10 is an algebraic number. We can let S is that number and then multiply both sides by 10, then minus 9. As it's a root of the question, all the coefficients are integer. It follows that we can easily prove it. In fact, we can show this property. Let S is P over Q and then multiply both sides by Q, then minus P. Very obvious, P over Q is algebraic number. Basically, when we want to show if it is algebraic or not, first we let S equal that number. Then write it as a polynomial equation with rational coefficient as I introduced just now. Therefore, its solution will be used in almost all of this topic. That's why I said at the beginning that you only need to remember this one algebraic definition. So don't worry about it being difficult. Now, let's challenge harder problem. Same thing. We make it into algebraic equation form. But the question is, can we stop at step 4? Well, the answer is actually no. By definition, all the coefficients must be rational. So, we continue to do the calculating operation until all the coefficients are rational. Finally, we already proved this variable S is algebraic. Alright, let's do the proving questions. If A is an algebraic number, B is a number, so that B squared equals A. Show that B is also an algebraic number. In fact, It seems very obvious it's algebraic, right? Well, as a mathematician and a math module, we need proof, right? Here is the proof. According to the questions, a is an algebraic number, so it can write as these polynomial equations. Also, b squared equals a. We plug b squared into the equation. As a result, b is algebraic number since the algebraic equation is Cn as power 2n plus Cn minus 1 as power 2n minus 2 and so on equals 0 with integer coefficients. Next, show that all transcendental numbers must be irrational. In these questions, we can use the following method. By the previous question, we already proved all rational numbers are algebraic. So we can say that S is algebraic number if and only if is rational number. And then we demonstrate with this proposition. Therefore, it means that S is transcendental number if and only if S is irrational number. By now, we have some idea of algebraic and transcendental number. Now you already. So is that pi is an algebraic number? We can actually prove it. We assume pi is an algebraic number and S equals pi. Then S minus pi equals 0. So is it algebraic? Some error there, right? Because by definition of algebraic number, we cannot let polynomial of coefficient be irrational. If you do that, then every number will be algebraic. So, since pi cannot be algebraic, therefore, pi is a transcendental number. Second thinking question, is that I an algebraic? In these questions, first, we need to know what is meant by imaginary number. Very simple. I is square root of minus 1. Assume S is square root of minus 1 is an algebraic number. Then we do this equation in algebraic polynomial form. So I is a root of the equation. S power 2 plus 1 equals 0 with integer coefficient. Hence, I is an algebraic number. In a nutshell, as you can see in the right-hand side picture, all rational numbers are algebraic and some real number cannot be expressed as algebraic number. A number S is algebraic if it satisfies this polynomial equation and all the coefficients are rational number or integer. If not, then it's a transcendental number. Moreover, we can notice that any number whose variable is generated by adding, subtracting, multiplying, dividing, rooting, and squaring is said to be algebraic. Therefore, the more complex the algorithm that make out as, the more steps are required to transform it to a polynomial and all the rational coefficient form. Alright, the above is my presentation. I hope this review will give you an idea of algebraic and transcendental number. Thanks for your watching.